Now that we got the Openfiler server up, in order to access the administration panel, all we need to do is go to HTTPS, the IP address that we've assigned to the server, and port 446. Once the administration panel loads, you'll be presented with a username and password login. The default username is Openfiler, and a password of password. Now, Openfiler has all kinds of options to be able to do things like NFS, local file sharing, disk management, and a whole array of other services. We're going to focus strictly on iSCSI for the purpose of this tutorial. So to set up iSCSI, we essentially have three different prerequisites that we have to take care of first. The first is going to be actually allocating the physical storage. In order to allocate the physical storage, we're going to click on System, and down here in the network access configuration portion, we're going to put in the subnet that we're going to allow iSCSI clients to be able to connect from. We're going to leave the type as share and then hit update. Once we see that the entry has been successful, then now let's go ahead and click on volumes. In the volumes section, in order to configure the physical storage, we need to go over here in the right-hand menu and click on Block Devices. Once we're in the block management view, let's go ahead and go down to the dev SDB disk, which is the disk that we're going to use to actually host or store the volumes that we're going to be serving via iSCSI, and click the link in the Edit Disk column. Here we can see that we have 100% of the disk completely free, and there are no previous partitions already defined. In order to define a partition, let's go ahead and go down to the Create Partition section, and we're going to leave the mode as primary, and we're going to set the partition type to a physical volume. We're going to leave the starting cylinder to be the first cylinder, and the last cylinder to be the last cylinder of available storage. This will give us the ability to utilize the entire 100 gigabytes of disk space. Once we have our partition defined correctly, go ahead and hit Create. Once the system allocates the partition, we can now see that in the partition section at the top, we have the primary partition that we just defined listed, and now it's ready to be used for a volume group. Something to note, which we can demonstrate with the dev SDA disk, is that in the event that you want to go ahead and utilize some of the storage off of your installation disk or from another disk that is being used by Openfiler, there is a slight caveat. We'll notice here that if we attempt to do exactly the same thing for the SDA disk that we did for the SDB disk and create an extra partition, that nothing is going to happen. As you can see, we define the partition, we hit the Create button just like we did with the SDB disk, but yet the partition didn't show up. And the reason for that is that for some reason with Openfiler, the starting cylinder needs to be at least 80 after the ending cylinder on the previous partition. So here we see the very last partition is written to cylinder 1213. And although normally we should be able to start a new partition on cylinder 1214, that is not the case. If we were to bump this up to, let's say, 1300, which exceeds that 80 cylinder threshold that I was talking about, and then attempt to go ahead and create a partition, now you'll see that the partition has been defined. So just a little trick to note if you're ever in a situation where Openfiler has a partition on a disk, it's trying to do something with that disk and it won't let you create a new partition even though there's available space. It could be because the starting cylinder that you've defined is actually too close to the ending cylinder of a partition that Openfiler is using. I'm going to go ahead and remove this partition just because we're not going to use this disk. Once we've defined the physical disk, now we need to create a volume. A volume can be spread across a single partition or multiple partitions. So again, for demonstration purposes, let's go ahead and go back into the block storage and just define one more partition. So what we want to do now is just create an extra partition here on the dev SDA space. That way we can kind of demonstrate how we can link multiple partitions together into a single volume. In order to do that, we do need to take note here, because of this particular disk that we're using, the dev SDA disk already has 3 primary partitions. We are allowed up to one more physical volume or one more primary partition on the disk. Now, if we wanted to cut this space up and we wanted, instead of having one partition, to be multiple partitions, what we would have to do is we would actually have to set this to extended partition. And what extended partition would do is it would set up a extended partition that would allow us to create multiple physical volumes out of that partition individually. You're allowed to have only 4 primary partitions, but one of those primary partitions can actually be an extended partition, which can hold additional logical partitions. For the sake of this demonstration, we're not going to be getting into all of that. We're just going to go ahead and create another physical volume that's about 40 gigs and we'll utilize the rest of the available space. Again, I'm setting the starting cylinder to 1300. That way it is above the 80 cylinder limitation here of what is available in our available block. And then I'm going to hit create. Once we see that that has been created, let's go ahead and go back to our Volumes tab so that we can actually assign a volume. Now, here in the Volumes tab, what we're doing is we are grouping together an entire volume that we're going to use for storage. Now, what we're really going to do is we're going to use this 95 gigabyte disk, which is a physical disk. But if we have, let's say, in the server, we've got multiple disks, and maybe all of the disks aren't very big. Maybe we've got 3 250 gig disks, for example. We can actually create physical volumes on each one of those physical disks at 250 gig apiece. At that point, all of them would show up just like the two that are displayed here are showing up. And then what we could do is we could actually select all of them, create a new volume group, and hit the add volume group. And what this would do is this would actually create one big volume that would be the combination of all of the physical volumes that we've included into that volume. So essentially all we're doing is combining multiple partitions on multiple disks into a single pool, and that pool will be able to slice up, and then that's what we're actually going to use to hand out to servers that are requesting storage. Now, to keep this demonstration simple, I don't like to use any space off of the disk that the operating system itself is actually stored on, because that way, if for whatever reason I have to wipe out the OS or do something, I do have recoverability options if I don't use that disk. So all I'm going to do for this example is we're just going to use the dev SDB disk. We're not going to use the dev SDA disk, and we're going to spell volume correctly here in the LUN volume, and then we're going to add a volume group. So this volume group will just consist of the one physical disk at this time. So now, once we've created the volume, we can see here up at the top that our volume is defined and that we have the volume as 95 gigabytes, and it's ready to actually add logical volume. So in order to create a logical volume, let's go ahead and in the same section here on the right-hand sidebar, click on Add Volume. Now here with Add Volume, if we had multiple volumes defined, we would be able to switch between those volumes. We only have one volume defined, so we're going to go ahead and just leave this as the LUN volume that we've created. And then down here, we're going to actually create a LUN that we're going to allocate to a server in a later tutorial. To keep things nice and simple, let's just go ahead and name this Test LUN 1. And for the volume description, we will just call it Test LUN 1. And now for the size of the LUN, I'm just going to go ahead and give it 25 gigs. And for the file system type, because we're going to be doing iSCSI, I want to go ahead and I want to use block storage. I don't actually want to put a file system of any sort on this LUN. What I want to do is just present it to the server as raw block storage. And that way the server, once it gets it, it will be able to format it with whatever file system that I would like to, or that's applicable for that particular operating system. So let's go ahead and click on block storage and then hit create. Once we've defined the LUN, let's go ahead and allocate one more by again clicking over here on add volumes, and let's create a test LUN 2 of again 25 gigs block storage. Now we're using up about 50% of our entire volume, and we have two slices or two LUNs that we're going to use to be able to present to a server in a later tutorial. Once we've completed all of these tasks, we are now essentially ready from a storage perspective to start serving the storage via iSCSI. So in order to do that, all we need to do is go over here to services, and we need to turn on the iSCSI target service. Once the service has been enabled, then we actually have to go ahead and start the service. Once the service is running, now all we need to do is actually configure the ACL, which is going to be the rule that's going to allow any iSCSI initiator to connect to the iSCSI target and request storage that we've sliced up and assigned to that particular initiator. So in order to do that, let's go ahead and go back to volumes, and then we're going to click on iSCSI targets over in the right-hand menu. We already have an IQN, which is the ID of the target, and all we have to do is hit add if we don't want to modify and just use the default target identifier. We don't have to actually change any information here. All we have to do is hit update, and that sets all the default values for the target. Once that's all set, then we go over to LUN mapping and click on LUN mapping. In order to map the LUNs, all we have to do is click on the map button next to the two LUNs that we've already created. That will actually map the physical storage to the iSCSI target that we've created. The last step is going to be to go to the Network ACL tab, and in the Network ACL tab, we see that we have the network assigned. We're either going to allow or deny access. Now, we only have the internal network interface identified here, so we want to add the iSCSI network that we created. So to do that, let's go to System, and here under Network Access Control, we need to add the iSCSI subnet. Once we've done that, then we can go back to Volumes, iSCSI Targets, Network ACLs, and then we can change the new network from deny to allow. This will allow any host on the 172.16 network to be able to request storage using its initiator identifier, the ability to request storage that we've assigned in the iSCSI target. So to reiterate the steps of what we've done is we've gone through and we've set up network access configuration to allow the proper subnet the ability to be able to contact the Openfiler target server. On the target server, we have taken a physical disk and created a physical volume out of that disk, which is essentially the same as taking a physical disk and placing a partition on that disk. From that physical partition, on that disk, we created a volume. That volume group is the pool of which we can create logical volumes or slices of storage that we can later present to servers via requesting initiator clients. We then mapped those slices or LUNs, logical units, to the iSCSI target that we created, and we set the network access rule for the entire iSCSI network to allow, which would allow any host in the 172 subnet that has a configured initiator client to be able to connect to this target and request storage. So now we've got the target all set up. Stay tuned for the tutorial on how to configure an initiator to actually request that storage.
Whatever.